All right. Thank you, everyone, for joining. So today we are going to dive back into a subject that we have grossly neglected over the last years, despite being a really, really core piece of silent infrastructure for many of us, which is design patterns for ontology. So the goal here is not just to document the kind of logical axioms and the structures of the ontologies that we are building, but to do this in a way that we can actually coordinate across communities. So we have huge efforts like the Euphino reconciliation effort that was very big in like about 2 years ago, where groups of ontology developers came together, negotiating, discussing about how to define common design patterns, to say things like, how do you record in a logical manner an abnormal morphology phenotype or similar. And when, let's say, a pattern like this was defined, we could save it, we could talk about it, we could reference it, and everyone could go ahead and implement this as well. So in this kind of things, of course, they sound a little bit geeky, but they're actually very, very important if we want to build something like a network of interoperable ontologies across the obosphere. So today we are going to hear a little bit of an introduction into how we build and use those patterns in the context of our normal ontology development processes by Ray. And hopefully this is going to be just the first one in a series where we want to reawaken a little bit of excitement about this subject, because it's really one of the core tools that we need to fulfill our vision of interoperable ontologies across all of our domains. So yeah, with this, Ray, thank you very much for volunteering to give this, and I'll take it away from here.
All right. Thank you, Nico, for the introduction. So I start sharing my screen. Okay. Can you see my slides?
Yes.
Thank you. All right. So today I'm going to talk about DOSDP patterns and ODK workflows. So there are basically, well, arbitrarily two types of ontology development. One is very fine-grained and editing ontology classes one by one, for example, using protege. And so I put a link to the desktop version in case you are not familiar with that tool, very useful tool. And the other category is template-based systems. So we are in a template-based system, we are editing raw data in the ontology, like labels, synonyms, axioms, cross-references, and other metadata separately from the OWL language patterns that are used to manifest them in the ontology. So I'm just listing a few of these systems, starting with DOSDP, but there are robot templates and OTTR templates as well, which I am not going to talk about today. All right, and if you are interested in some further reading, so there is a link in the obo-academy on the obo-academy website, so you can. So I'm not going to cover everything, or there are many details that I don't have time to discuss, but you can dive more deeply in for example, in robot templates if you look up the documentation on the obo-academy website. All right, so why should we use a template-based system? So one justification is that using templates removes the burden of writing all axioms. So editors with very limited ontology training can actually curate even logical content by focusing on the domain-specific data that they have an expertise in. So templates allow the editing of many classes simultaneously in one table. So this makes the system very scalable. Because we are using templates, so that by default encourages the alignment of ontological modeling of similar concepts. So we are forced to use the same templates, which helps ontology alignment. So what I think Nico has already mentioned. So for example, UFIN uses community-wide templates, and that helps ontology alignment from different domain-specific ontologies. So the template-based system also discourages Rococo-style OWL development. So because you are trying to fit everything into a simple pattern, you don't have time or capacity to over-axiomatize or do some very elaborate one-of-a-kind editing of axioms that looks impressive but don't really deliver much functional utility. So if you are interested in some design concepts, how to avoid Rococo OWL, so you can see on the screen, and so I have shared the link to my slide, so you can click on the link and read more from Chris Mongol on this subject. All right, so that's simple ontology design patterns, or DOSDP, the DOSDP system. So that separates data and the templates into two files. So this is in contrast to, for example, to robot templates, where you have both the templates so I mean the axioms or annotation templates in the header of a table, but in the DOSDP system we have separate templates that define how the data, which is coming from a separate table, a TSV format file, how that data from the TSV file is compiled into ontological OWL axioms. So the reference I have listed here, the paper that describes the DOSDP system, and also a link to the GitHub project page where you can find useful information. All right, so the DOSDP system, this is just an illustration that that there are separate pattern files with the annotations and logical axioms that are shared across many different ontological classes, and an example of a filler table with some data which are, so in this case these are components from other ontologies, and and these components are used to create new ontological classes using the DOSDP system and ODK. All right, so the first file I show here is a so-called YAML file, which is YAML is a human-readable data serialization language, and it is commonly used for configuration files. And so one great advantage that it is relatively more human-readable than many other serialization formats. So, for example, JSON. So the DOSDP pattern template components use a JSON-compatible subset of YAML syntax, and this allows human-readable definitions and also defining logical axioms as well as some generic annotations. All right, so the DOSDP pattern template has a nested data structure in YAML syntax. So at the top level, there is a set of keys, and those are specified in the DOSDP standard. So I will provide you with a link later to the DOSDP standard. So each key is followed by a colon and then a value, which may be a text string, a list, or another set of keys. So list items are indicated using a dash, and nesting is achieved by indenting with some certain number of spaces. So the spacing is important, and I will show you some tools to check if you are not overly familiar with the YAML syntax, how to check if your indentation is correct or not. So at the top of the DOSDP YAML template, so there are pattern level keys. So we have, for example, the pattern name, which is also identified. So we use this pattern name also for the file name, which you will also see in the practical demonstration. And so there are a set of fields that specify general information about the pattern. So, for example, the name, the description can be something that is useful for editors, how to use this pattern. The IRI is, so in the ontology world, it is quite important. And so because these templates can be shared, so contributors can list their ORCID IDs. So on this slide, you can find a link to the DOSDP schema documentation if you are interested in more detail. All right, so there are in a DOSDP pattern template, there are sets of dictionaries that map labels to IDs. So any readable name can be used, but by convention, we use class labels. IDs must be obo-query style, for example, as you can see on the screen, CL colon and 7-digit number. So we defined the classes and relations in this section. There are different kinds of variables, and so in the YAML template we need to define what type of variables we are going to use in there are template fields where you specify the content of classes produced by the template, and so one notable thing is that this printf format placeholders. So where there is a placeholder, so that will be replaced by a data item from the TSV filler table, and so they are filled in order of appearance. So, for example, the first %s placeholder will be a neuron type entity, and the second one is a region. So I guess it will be so you can define new neuron types that are present in a certain brain regions from existing cell ontology and Uberon terms. You can also use the annotation fields, and so one of the most important sections is the logical axioms. So you can use equivalent class axioms, subsumptions, and general concept inclusions in DOSDP pattern files. So here is an example of a data table that is used for the DOSDP system, and as you can see, so the headers must match those variable names that are in the DOSDP YAML template, but we will see in more detail soon. So here are some template examples from the ontology of biological attributes, which is largely developed by using DOSDP templates. Okay, to summarize, so the next step, so once you have the templates, you can use the DOSDP tools, which are part of the ontology development kit, to convert your templates and data into all axioms. And so now I'm going to demonstrate how to do some DOSDP template development and how to convert your DOSDP templates into all axioms and include them in an ontology. So if you want to follow what I'm doing on your computer, so first you need to have Docker and the ontology development kit installed on your machine. So luckily the obo-academy has some instructions how to do that, and we are going to use GitHub to share this ontology and for development, so you can follow the obo-academy section on how to create a repo with a blank so I mean an ODK ontology from scratch and put it under Git version control. And if you are not familiar with Git and GitHub, well, it's too bad, but you can. All right, so you can read on also on the obo-academy pages, and it is well worth getting familiar with Git and GitHub. So I have set up just a test ontology, and the link is here. All right, so the first step is let's create a DOSDP pattern tab. Okay, so my test ontology is a hypothetical physiological process ontology based on the idea that there are some physiological processes that are not yet or not well represented in the gene ontology biological process branch. So most of these the README are filled out. So I have used ODK to see this ontology, and so this is a standard way how the README file is created by ODK. So some of the links might. So I don't know if what it. Okay, so maybe this my choice of name is not the best for this ontology, but anyway, for testing, I think it will do. All right, so let's create a template first. So the ODK provides a standardized structure for the file system in a ODK ontology, and all pattern files, so they live in the source patterns DOSDP directory. And so helpfully, ODK has created an example template with some certain things already filled out. So you can either start with this template, or you can create your template from scratch, but you need to follow the structure that I showed you in my earlier slides. So you need to provide a pattern name, and so you would name your file based on the pattern name. So in this repo, so this file is called example YAML. But I would like to create a chemical homeostatic process template. So I start with the pattern name, and this must be identical with the file name. We provide a pattern IRI, which is also based on this pattern name. So we can provide a description of this template, what it is and what the intention is with this template. So I want to use this pattern for cellular or organism level physiological processes where the stability of a biologically relevant chemical entity that is internal to an organism or cell is maintained. So basically, this is what we call homeostasis. So I put my ORCID ID here, and I define what ontological classes I am going to use. So I'm going to use chemicals from CABI, the ontology of biologically relevant chemical entities. And so I want this ontology to be an extension of the gene ontology biological processes. And so for this pattern, I am focusing on homeostatic processes, which there is already a Go class, and the query is shown here. And I am going to use a relation regulates level of. I can also provide exact some synonym types. If I wanted, I could include broad or narrow synonyms and other types of annotations. So just to make it easier to read, so I named the one of the variables chemical. So this will be a chemical, obviously, that I want to use in the pattern. And the names or labels for these classes will be automatically generated by replacing this placeholder. So for example, if I want calcium homeostasis term, so I provide in a separate table the CABI ID for calcium ions or atoms, and so the name will be automatically generated as calcium homeostasis. I can provide some synonyms automatically. So for example, calcium homeostatic process, and so I can provide annotations for the generated classes. So this is in contrast to the contributor to this pattern. So this contributor will be provided. So the ORCID ID will be provided in the CSV file, and you can actually input a list of contributors if there are more than one editors who contribute. So we usually write a text definition that is general, very generic and true for every expected class. That so here, biological process involved in the maintenance of an internal steady state of X. So let's, for example, calcium. And so the placeholder will be a chemical coming from the data table. All right. So the next section is the logical axiom. So we provide an equivalent axiom in Manchester syntax O. So the definition will be homeostatic process, which is Go 0042592, and the relation will be relation ontology to term, regulates levels of sum, and then there is a placeholder for the specific chemical that you want to use or to generate a class. So I have actually created this file. So let's so how do we check if my YAML syntax is correct or not? So I mentioned that YAML is so the indentation is very important for YAML files, not files. So I will just make an intentional error, and so I can use, for example, a linter, YAML linter, to check if my syntax is correct or not. Oops, there is an error on line 13. Okay, so there are plans to include this syntax checking in ODK. So in the future, you don't need to check it. So I mean, install a link immediately by yourself. So I am using this YAML lint tool, and so here is a link. that tool how to install it if you would like. All right, so I have saved this template. I'm checking it, and no errors are so as far as syntax is concerned, this is fine. But so DOSDP is very simple, but still you can make errors. Actually, my experience is that so especially when you start out, you might have created a template that is not 100% correct or complies with the DOSDP schema standard. So there is a tool to validate your DOSDP YAML template. It is part of the ODK. So if you have the ODK toolkit, you can use DOSDP validate and you specify the input file, and the result is that validation completed without any issues to report. All right, so it means I have a syntactically valid template that complies with the DOSDP schema standard. I also need to create a data table. So in preparation to this tutorial, so I have already created a table, and so it has the correct header, and I filled in some chemicals which I want to create homeostasis biological process for. So I need a data table. Okay, so it looks like somebody already created a table that I can use. And it is in TSV format. And looks exactly what I want. It has the correct header. Okay, so the next, and so what I need to do is compile all axioms from the DOSDP template and the filler table. To do that, we can use the ODK tools. So as I mentioned, DOSDP tools are part of the ODK toolkit. And so that is information on how ODK works with makefiles in general on the obo-academy side. But briefly, you need to be in an ODK type ontology setup, you need to be in the source ontology folder, and then you can use make and we can create the all definitions by running this command that I have included on my slides. So let's see what happens if I run this command. So remember now the data in the filler table is used to generate new classes. So if I provided 6 chemical entities for this pattern, so I expect to have to generate 6 new classes in this ontology. So there are different ways to check if you have generated your intended classes or not, but for simplicity, let's just open Protégé and look what happens. I start the reasoner and I generated some homeostasis classes. So it is always worth doing some quality control checks when you use any tool. And so one frequent problem is, I don't know if you can spot it. All right, so I didn't fill in the defined class name column because the class name will be automatically generated. But if I wanted, I could override that with another and provide another label. So I made galactose and different kinds of homeostatic processes, but I can spot that there is one strange-looking class. So it is just IRI homeostasis. It doesn't really make sense for humans. So something is missing, and anybody has an idea what is missing here? So if I am importing Cabby terms, and why is this term strangely displayed in Protégé? Probably you have already figured out, oh, it might be something wrong with the imports. And so that is a frequent mistake I have made when I started out. So I didn't know, or I forgot to refresh the import. So this Cabby class is a new class for my ontology, and it is not yet imported into the ontology. So I can refresh my cabby import, but it usually takes 10 minutes, and we have probably 10 minutes left. So I can start it, but so I've already tested, and indeed that is the problem. So if I refresh the import, then that fixes this problem with the label, and also the EQ is also incorrect, so it doesn't show the label, and sometimes because this class is not properly imported, so even there could be other errors as a consequence. So I can refresh cabby, but it usually takes quite a long time, even though we are using a slim. All right, so it is always worth doing some quality control. So check your ontology and protege, check your new terms if they look as you expect them to look like, but there are, you can also set up some GitHub actions to do automatic checks, and you can specify that for your ontology. All right, so this is running, and hopefully it will. Okay, I don't know if it will finish before the end of the tutorial, but if you have any questions, please, here is the time to ask. And before I forget, so I would like to thank Nico and all the people who contribute to ODK, and those people who developed DOSDP tools, and the very useful resource of obo-academy, because you can find many pages with loads of useful information if you want to use templates or other tools for ontology development.
Thank you very much, Ray. That was very, very helpful. Very nice tutorial. Does anyone have any questions for Ray to start with? Also, general questions are super welcome. If you, for example, if you're not an ontology person and you don't know what's the point of this whole thing, you can also ask, or if you want to ask some technical details. And just for you to maybe start a little bit thinking, I will ask a question. So, Ray, do you ever work the other way around? Like, instead of curating, let's say, the TSV files and turning them into OWL and building an ontology, do you ever try to go from the ontology and extract the DOSDP tables for any use case?
No, but sometimes I check the logical axioms or lift. So for example, this axiom I used in this template, I lifted from Go. Probably it was made by David.
Nice. Yeah, for many of us, like maybe this you didn't touch this, but this is one kind of like workflow, and I guess like this is one thing. So today we've learned a little bit of how do we kind of build these patterns and some basics about how to run them with DOSDP tools in the context of ODK, but for many of us, so there's a wide variety of workflows in which these DOSDP patterns are actually useful. So not just for building ontologies, but actually you can use them for example, for quality control as well. So, or for augmentation. So one thing that we do, for example, in Mondo, or we haven't done for a while, but we should be doing it again because we did it in the past, is we take the patterns, we match the patterns against whatever is already in the ontology to get, let's say, these tables that you now manually curated, so you can see the entities that are linked from the logical definitions or and similar. You can see them in rows, and then we again use DOSDP tools to turn them into OWL to augment, for example, the ontology with the synonym patterns that you have to find in your DOSDP template. So you could say in your DOSDP, like you showed before, with the process synonym, for example, or you could think of many different kinds of synonyms. You could first do a match, then generate the table, and from the table you can generate new synonyms that you can merge in the ontology, which makes the ontology more rich in terms of synonym content. But also, what is also another cool thing is that you can use it a bit for quality control. So you can do things like, okay, you match all of the terms that adhere to your patterns, and you can, for example, test, do all your terms adhere to patterns? That's the first star. Were there some naughty people that were building Rococo axioms and no one saw them? And like huge ontologies like the one that we are building, we don't really know exactly all the logical axioms and the 20,000 terms, 25,000 terms, 30,000 terms of the ontologies that we have. And this way we can kind of see immediately, okay, all of these terms seem to adhere to patterns that we have defined as curators, but there are these like 10 ontology terms down here that don't link to any pattern, and maybe we need to revise them or create new patterns for them. So yeah, that's, I guess, just one addition. Does anyone else want to ask something else? Any curiosity about the workflows? Right. If there are no more questions, then I want to wrap this meeting up with a very strong kind of foreshadowing of the future. So we do want to encourage anyone that is working in ontologies and building ontologies to really like make pattern development some part of their forefront of ontology development. So basically, in an ideal world, you should never create a logical axioms that doesn't adhere to a pattern at all. So if a curator, for example, adds a term to Uberon or adds a term to HPO or something like that, it should always be we should always have a pattern defined that really says this is how you build a term of this type. And I would really like to encourage anyone that's building ontologies to think and learn about patterns and build workflows that put patterns first in the development process, even if you're using Protege and not like this kind of table curation process, and get more sensitive to the idea that we are that we want to let our processes be guided by these kinds of patterns that we can also reuse across different ontology projects. With that, well, thank you again, Ray. Excellent. Thank you for your work, and see you all. Have a great Christmas, and see you all next year.
Thank you.
Thank you. Happy holidays.